This is part 11 of the design patterns tutorial. In this session, we will discuss what is builder design pattern, implementation guidelines of builder design pattern, and we'll take a look at a real world usage example to implement the builder design pattern. Please refer to the previous parts of the tutorial before proceeding. Builder design pattern belongs to creational patterns. As per the Gang of Four definition, builder design pattern provides a way to separate the construction of a complex object from its representation so that the same construction process can create different representations. To simplify this definition, we can say that builder design pattern solves the situation of increasing constructor parameters and constructors of a given class by providing a step-by-step initialization of parameters. After the step-by-step initialization, the builder pattern takes care of returning the resulting constructor object at once. Now let's take a look at the implementation guidelines of the builder design pattern. We need to choose builder design pattern when we need to break up the construction of a complex object and when we need to create a complex object and it should be independent of the parts that make up the object, and when the construction process must allow multiple representations of the same class. Now let's take a look at this illustrated diagram. The builder over here defines a template for the steps to construct the product. To simplify, builder specifies an abstract interface for creating parts of a product object, whereas the concrete builder implements the builder interface and provides an interface for getting the product. And the director is responsible to construct the object through the builder interface. The product is the main object that's constructed and it represents the complex object. Now, if you recap the previous session of the abstract factory design pattern, we have implemented the business case to allocate computers to the contract and permanent employees based on the employee type by leveraging on specific set of rules during the employee creation. If you have not gone through the abstract factory example, we request and encourage you to view the tutorial before proceeding. Now let's consider a business requirement where a company provides an option to build the configurations of the system which is allocated to the employees. Now let's open the Visual Studio and bring up the employee portal application that we have been using in the previous sessions. First, we need to create a column that holds the employee system configuration details. To make the things faster, I have already added system configuration detail column to the employee table and I have updated this employee model.edmx file to reflect the latest changes. Also, it's not mandatory that you need to create single column to store the entire system configuration details. Based on the requirement, we can further normalize this table structure. However, I have opted to create a single column to simplify the scope of this tutorial. For more details on normalization, please refer to our SQL Server tutorials. Let's now proceed with our next step. Let's open the employees controller and add an action method to provide an ability to choose configurations to build the system. Let's add an action method, public action result. Let's call this method as build system, which accepts input parameter as employee ID. Let's return a view by passing this employee ID. Let's compile this application. Let's right click on this controller method and choose add view. Let's name this view as build system. Let's click on add. Notice that it has created a new view called build system under employees folder. Based on the requirement, let's say we need to give an ability to choose memory and hard disk size while configuring the system. I have already created the code related to the view in my notepad. Let me just copy that code over here. Now if you notice the code, I have already created two drop-down lists to choose the value of RAM and hard disk drive. Further, while configuring the system, user can opt for 8 GB, 16 GB or 32 GB as the memory and 500 GB or 1 TB as the hard disk size. As we progress by, I'll add more configurations to build a system. Let's now switch back to the employees controller and add a new action method so that we can capture all these details on the form submit. Let's switch to the employees controller. Creating an action method, let's create a new class. Right click on the web, add new item and choose a class under code, and let's name this class as computer system. We are calling this class as computer system since we are going to configure the details of the computer system. Let's add some properties which would be private string and name this property as underscore RAM private string underscore HDD size as another property to capture the hard disk drive size which is chosen. And let's create a constructor public computer system, a public constructor, as well as another constructor which accepts the parameters of RAM and hard disk drive. Let's assign these values to the internal properties, saying underscore RAM equal to RAM underscore hard disk size equal to HDD. Let's also create a new method, public string build. Let's name this method as build so that it's going to build the system by using the RAM and hard disk size that is being passed into these constructors. Let's create string builder sb equal to new string builder. Let's resolve these issues by using system.text, and let's say sp.append string.format of, let's say, RAM colon 0 comma underscore RAM, which is assigned in the constructor. Similarly, let's do the same thing with the hard disk drive. It should be HDD size equal to underscore HDD size. Now let's return sb.toString. Let's now switch back to the employees controller and create our action method to build the system. The previous action method would be a HTTP GET, whereas the submit action method would be a HTTP POST. Let's create the action method public action result, and the action method name would be build system, which accepts the parameter as employee ID comma memory that is being chosen in the view, and it passes back the hard disk drive size that is chosen from the view. Based on the employee ID that is being passed, let's retrieve the employee object from the database. Let's say employee equal to db.employees.find, and let's pass this employee ID as the input parameter to the find. Now that we retrieve the employee, let's build the system. Let's instantiate the class computer system equal to new computer system. Notice that the computer system has got two constructors accepting the input parameters for RAM and hard disk drive size. Let's pass the RAM, comma, hard disk drive size as well. Now that we have retrieved the employee details, let's assign the system configuration using this computer system class. Let's say employee dot system configuration details equal to computer system dot build. The build method will retrieve the system that is being built and it gets inserted into this system configuration details column. Now let's say we need to update this employee object back to the database. So let's say db dot entry. Let's create an entry for this employee object with a state which is entity state dot modified, as we are modifying the employee back to the database. Let's say db dot save changes to save these changes to the database table. Once we have successfully saved the changes, let's redirect the view to the index view by using redirect to action, and let's pass index as the parameter. Let's compile this application. Look at that, compilation succeeded. Let's now switch to the index view. Let's open the views and choose index view and add an action link to configure the system. Let me just copy the link that have it in my notepad. Now let's also create a label to display the chosen configuration details. Let's keep that label over here after the computer details. So if you take a look at this, we are displaying the system configuration details that are already configured for the existing systems. Let's switch to the employees controller and run this application. Let's click on the employees tab and choose George, who is the manager. Let's click on build system for George. Let's choose the memory as 16 GB and the drive as 500 GB, and let's click on create. Look at that, we have successfully configured the Apple laptop i7 for George, who is a manager, without using any design patterns. Now let's switch back and revisit our code. Now you may be wondering why we need to use builder design pattern when this approach is working as per the requirement expectation. To answer that, there are few problems with the current approach. Let's say if we need to enhance and provide an option to configure graphics, screen size and other properties, then we end up creating more constructors to accept additional parameters that we are going to add. Let's also assume if we need to enhance the current code itself to segregate the configurations differently between a laptop and desktop. For example, if we need to choose keyboard and mouse related configuration for desktop, which is not applicable for laptop, then the current approach is not feasible and it becomes complicated. In these kind of situations, builder design pattern comes to our rescue to address these problems. In the next session, let's discuss how we can address these problems using builder design pattern. Thank you for listening and have a great day.